Hello, good morning one and all. In today's lecture, we will going on the bracketing method, or it is also called as a interpolation method. Okay, already we have seen in the last lecture what is the graphical representation, algebraic and transcendental equation. In today's lecture, we will see the details of the introduction of the roots of equation. Okay, in that first we'll see the bisection method. Okay, bisection method, it is so known as interval halving method, binary chopping method, interval halving, or Blonzano's method. We'll see one by one. First, you know what is mean by root. Okay. In applied mathematics and engineering, there are various problems are in the form of determine the roots of equation. Okay. The great importance is given to such problem which are in the form of fx is equal to 0. We have seen this graph, this fx versus cx. If you want to find out the root of that 2 points, we can't find out the roots because there is a no roots. Okay. In second case, see that this apex here is a this point is intersect to the x-axis. Means you will get the apex is equal to 0. Where apex is the function either linear or non-linear. This root is called as a one root. One root. In third case, see here 2 points are intersect to the x-axis. Okay, then you will get the two roots. You will get the two roots. If there are a 3 points are intersect, okay, then there are we will get the three different roots. Okay, that value are satisfy the condition of the roots. Okay, similar way here you can see there you will get the two roots because there is a 2 points are a intersect to the x-axis. Fx is equal to 0. In that condition, this function is called as a discontinuous function. There we want to the solve that type of problem need the special method. We'll see what is the bisection method. In the bisection method, see, we want to the first assume the two initial guesses are required. Okay, roots are required. In this graph, see here I have shown this point is a intersect to the x-axis. Black spot is there. This is called as a root is there. Root is there. Okay. First, we want to the guess to initial point. Okay, or to value. Okay, if two initial guesses are given, suppose x1 and x2, then the first approximate value of the root of equation lies at the mid value of x1 and x2. Okay, here I have shown there is a two value xl and xu value. XL is the lower value and XU is the higher value or upper value. Upper value. Okay. The what is mean by bisection method? When two initial guesses for the root are required, the guesses must be bracket or be on the either side of the root as shown in the figure. Means here we want to the assume two initial guesses in such a way that the root lies between the two guesses. If there is a, for example, 1 and 2, initial guess is a 1. Suppose x1 is equal to 1, this is the first initial guess, and x2 is equal to 2. This is the second initial guess. Okay. Therefore, we restrict the value of root in between 1 and 2. 1 and 2. Okay. This is nothing but the bisection or half interval method. If one root of the real and continuous function, then you will get the fx is equal to 0 is bounded by the value of xl, x is equal to xl, lower value, and x is equal to xu, then upper value. Okay, there is one condition is given to find out that root. F of xl into f of xu, okay, is less than 0, is less than 0, or f of x1 means again we can say the y1 and y2, okay, that both have the alternative sign, okay. The function change sign on opposite side of the root, then this condition will be satisfied. One is positive and another is a negative, then this condition will be satisfied, okay. This actual root lies where the curve intersect the x-axis. Here shown that root. Let we can say the y is equal to f of x is equal to 0. Okay, all of you getting? We'll see the details. First, see, this is the another graph. Here I have shown the few steps of the bisection method applied over the starting range a1 f of a1 to f of b2. Okay, the bigger red spot or dot is the root of the function, means f of x is equal to 0. This is the bisection method in the mathematics. The bisection method is a root finding method. Okay, when you find the root, then we are using the bisection method. And when you apply that, when you given any continuous function for which one knows two value with opposite sign, means one value is a positive and another value is a negative. This method consists of repeatedly bisecting the interval defined by this the value and the selecting subinterval in which the function changes the sign and therefore must contains a root. Okay, already I have told we require two assumption. Okay, that assumption must have the opposite sign. Okay, it is very simple and robust method, but it is also relatively slow. Because of this, you will get the approximate solution, not correct solution. You will get the approximate solution, which is used as a starting point from more rapidly converging methods. Okay, remember that. Here we will get the approximate value of the root, means we want to use the number of iteration and find out the approximation value of that root. Okay, then there are different steps are given when you given the numerical and solve that numerical with the help of bisection method. Then guys, you should remember the 5 steps. You should remember the 5 steps. Okay, in the first step you have to check whether assuming initial guesses are right or wrong. Okay, in the first step you have to check the initial guesses are given right or wrong. Okay, uh, for example, you have to some numericals you have given the initial guesses, they are provided with the with problem statement. Sometimes they are not providing. At that time you have to assume the initial guess. Okay, suppose for x is equal to 0, you have to assume. Okay, and second is a for x2 is equal to 1, for x2 is equal to 1. Okay, this is the your second guess. You have to check, you will get the x1 is equal to 0, they are given the positive or negative sign, or f of x2 is equal to 1, x2 is equal to 1, they are given the positive or negative sign. Okay, once you have checked in the first step, then you have to check that this f of x1 into f of x2 is less than 0. Okay, because that is both have the opposite sign. Okay, both have the opposite sign. Then the initial guesses x1 and x2 are right. Otherwise, you have to choose the another gases. Okay, all of you getting? In the first step, you have to assume two initial guesses, x1 is equal to and x2 is equal to, and you have to put that value in the given function and check that the initial guesses x1 and x2 having the opposite sign or not. This is the first step. Okay, in second step, you have to apply the bisection method iterative formula. What is the bisection method iterative formula? You have to use that x3 is equal to, first in the first step we have assumed the x1 and x2 value. In the second step you have to calculate the x3 value using x1 and x2 value. Okay, you have to calculate the mid of that two. Then how to calculate the mid of that two? Here let x3 be the first approximate value of the root. Okay, here in the second step we have, this is the x3, suppose this is the x3 value, this red dot is the x3 value, we want to the calculate that value. X3 be the first approximate value of the root. Then according to that method, the name suggests bisection or half interval. X3 is equal to what? X1 plus x2 divided by 2 is there. Then you have got the value of x3. Means in the second step, you have to calculate the value of x3 and check that value is either positive or negative in the third step. Okay, step number 3, what is the step number 3? You have to check whether the f of x3 or we can say the y3 is either positive or negative. Okay, how to check? You have given the numerical, suppose you have given numerical x square plus 2x plus 1. Okay, that numerical is given, you have to put the value of x1 x2 in that numerical function. Then you have to check the value is a positive or negative in the third step. Step number 4, once you have got that value positive or negative, after that you have to replace the value of x1 or x2 by x3. Okay, here remember that in the step number 4 you have to replace the value of x1 or x2 by x3, whose that f of x, that is f of x1 or f of x2 will have the same sign as that of f of x3. You have to check that what is the sign of x1, what is the sign of x2, and what is the sign of x3. Okay, or what is the sign of f of x1, f of x2, and f of x3. This is because we have to satisfy the condition. Which condition we want to the satisfy? This one, f of x1 into f of x2 is less than 0. Or also we can say the f of x1 into f of x3 less than 0, or f of x2 into f of x3 is less than 0. As you know that, suppose f of x1 is equal to positive value, will get f of x2 again will get the suppose negative value, and f of x3 will get the positive value. Then x1 and x3 having the positive value. That's why you can replace x1 guess with the value of x3. X1 guess with the value of x3. So that you will get the new formula f of x1 uh, f of x2 into f of x3 is less than 0, or f of x2 into f of x1 is less than 0 in the fourth step. Okay, means we want to the find out the new guesses for the x1 and x2. X1 and x2, you will get the new guesses. And last step, you have to check whether the mod of x2 minus x1 is less than accuracy or not. Some examples you have given the accuracy, they are required 0.001 or 0.01. you have to check that value x2 minus x1 is less than accuracy or not. If this value are not less than accuracy, then you have to repeat the step 2 to 5 till we get mod of x2 minus x1 is less than accuracy. Okay, again you have to take the number of iteration up to when we'll get this value x2 minus x1 is less than accuracy. These 5 steps you should remember. Okay, all of you remember getting what I am telling. In the bisection method you have to use the number of iteration up to till we get mod of x2 minus x1 less than accuracy, then you will get the root of equation for given accuracy. Okay, that value is satisfy that given function. Okay, all of you getting. Then next is the flowchart for the bisection method. First we'll solve the some examples on the bisection method. I will solve that example on the blackboard and I will upload on the YouTube. Once you have complete that, then we will going on the flowchart. Flowchart. Flowchart of the bisection method. See, first uh, you have to draw the flowchart for the bisection method. Guys, remember that in offline examination you will get the flowchart also. That's why you know how to draw the flowchart. First, we want to define the given function. You know the first chart we are using the symbol. Then define the y is equal to f of x. Means define the given function in this format y is equal to f of x. Then once you have defined, then you have to read that value. Means take the input data, like assume the initial data. We have seen in the first step we want to assume if you have not given the x1 and x2, okay, up to the n value. Sometimes you will get the 3 variable, 4 variable. Take the input data like initial guesses x1, x2 up to the n and accuracy from the user. Accuracy from the user. Sometimes they have given the accuracy. Once you have set, assume that data, then you have to calculate the value of y1. It is nothing but the f of x1 and y2 f of x2. How to calculate that value? We have seen if you have given the function, then that function you have to put the value of x1 and x2, then you will get the y1 and y2. Again y1 means f of x1 and y2 means f of x2. Once you have put this value, find out that value y1 and y2, then you have to use check that y1 is equal to f of x1 and y2 is equal to f of x2 such that both have the opposite sign. Okay, if you want to the two different conditions, then you have to use the while loop. While loop. Okay, we want to the check that both y1 and y2 have the opposite sign. Okay, then again this condition we want to the use y1 into y2 is greater than 0. Okay, check that. If yes, then we are going to the read that x1 and x2 again. Okay, that condition y1 is y1 into y2 is greater than 0. If the yes y1 into y2 is greater than 0, then again we want to the put the sum value for the x1 and x2. Again you have to check this condition y1 is equal to f of x1, y2 is equal to f of x2. Again we are going to the while condition and that check. If this y1 into y2 is less than 0, less than 0 means there is a no condition is there. Okay, then check that while that once the condition of y1 into y2 is less than 0 is satisfied, then you have to check whether that mod of x2 minus x1 is less than accuracy. If not, then again you have to calculate the root of x3 is there. For I is equal to 1 up to the s to n, you have to check that. If yes, then again you have to use the x3 is equal to x1 plus x2 divided by 2. What is this? This is the bisection method iterative formula. With the help of that, again you will get the y3 is equal to f of x3. Okay, f of x3. If no, then again here print the root x3 and end this program. Okay, here check if y1 into y3 is less than 0. If yes, then y1 should be positive, okay, and y2 should be negative, and y3 again negative, then y2 has same. That sign as that of y3, so replace x2 is equal to x3, x2 is equal to x3, and y2 is equal to y3. When check if y1 into y3 is less than 0. Okay, that condition here is a greater than 0, then we are going to the no. If less than 0, yes, then we are getting the x2 is equal to x3 and y2 is equal to y3. Okay, if no, then check that y1 should be positive, y2 should be negative, and y3 should be again positive. Then y1 has same sign as that of y3, y1 having the same sign as that of y3, so replace x1 as a x3 and y2 say y3. The above process is repeated till mod of x2 minus x1 is less than accuracy. Then after that, you should finally, when you will satisfy that condition, mod of x2 minus x1 is less than accuracy, this condition is satisfied, then the final root is given, that x3 is equal to x1 plus x2 divided by 2. Then after that, you should print the root of equation x3 on the output screen. Okay, we'll see after solving the numerical, you can easily understand this flow chart. How to use? We'll use the MATLAB software, okay, and solve the given numerical. Before going on that, we want to the clear complete the example parts. I will upload that example in the next lecture. Today we'll stop here. Okay, thank you.